Hey guys, and welcome to this tutorial on how to plot residuals from the simpleFoam solver in OpenFoam. So as an example case, I'm going to solve for turbulent flow through a pipe section. We can go ahead and take a look at the mesh. It is seen here. So we got inlet here with uniform velocity, outlet, and then a wall here, mesh refinement close to the wall, and then a line of symmetry here. The whole thing is a wedge. I'm not going to show you how to set up the case files. I'm only going to show you how the simpleFoam stuff works. So let's take a look at the control dictionary. So again, the simpleFoam is a steady state solver, so there's no time involved in the equations. So here the way to set up simpleFoam is to put delta t to be 1. In that case, n time means the total number of iterations. The whole point of simpleFoam is that the algorithm should converge to a steady state solution before it reaches the last iteration. So if your simpleFoam solution does not converge by the time it reaches the n time number of iterations, then you need to either ramp up the total number of iterations or do some other modifications. Let's take a look at the finite volume solution. Here, where to control your residuals is here under Residual Control. So here you put the tolerances that if these variables changes with a factor less than this, then and if all of them changes with a factor less than, with a number less than 10 to the minus 4 in this case, then simpleFoam will stop. The reason I don't have simply the u here, which is the u vector containing ux, uy, and uc, is because I'm solving a 2D simulation, and in my case the velocity in the c direction, uc, does not converge as the other variables do. But it's not really a point since I'm doing a 2D simulation. I think this is because I am using a wedge boundary condition, or a boundary patch name, but this is not too much to worry about. So let's go ahead and solve the case. Now, instead of simply just writing simpleFoam and pressing enter, in that case the log will be displayed in the terminal. I'm going to redirect the log to a log file called log.s. In this case, you can see a text file is being made, which contains all the log that normally would be displayed in the terminal. You can see the progression of the simulation by all this time or iteration folders being displayed in the case folder. So now you can see it has converged after 201 iterations, even though we had 1,000 iterations as the maximum number. So simpleFoam has indeed been able to find a steady state solution. Now, I've made this GNU plot script. I will link in the description to the place on the web where I found this piece of code. It's not very difficult to understand. All it does is that it reads through the log.s script, where we have displayed all the log, and then it searches for the residual values for the different variables, so ux, uy, uc, p, k, and epsilon, which is k and epsilon is the turbulent variables. So to plot it, we just initialize GNU plot, and then load was plot. So here you can see we have plotted the residuals, and indeed they are converging to a smaller and smaller value as we want. The only variable that does not converge is the UC variable, but I think this is due to the wedge boundary condition. So this is not too much to worry about. Alright, that's how you plot residuals in OpenFoam.